The purpose of this lesson is to learn about combination circuits. Let's start with one of the basic laws of circuits, Ohm's law. Here is a circuit where R is the resistance, V is the voltage, and I is the current. According to Ohm's law, V equals IR. We need this for our calculations in combination circuits. To do this, first we have to talk about basic circuits. The two types of circuits are series and parallel. Here is a series circuit with two resistors, R1 and R2. The battery voltage is V and the current is I. The total resistance in a series circuit is equal to R1 plus R2. The current remains the same throughout both resistors. If V1 is the drop across R1 and V2 is the drop across R2, then the total voltage is equal to V1 plus V2. Now here is a parallel circuit with two resistors, R1 and R2. The battery voltage is V and the current is I. The total resistance in a parallel circuit, RT, is equal to 1 over R1 plus 1 over R2. The voltage V remains the same across both resistors, while the current is split. I1 is the current through R1, and I2 is the current through R2. Now let's talk about a combination circuit. A combination circuit is a mix of series and parallel circuits. R1 and R2 are the two resistors split in parallel, and R3 is in series with them. Therefore, this is a combination circuit. To find the total resistance, first we see that R1 and R2 are in parallel. So using the formula that we taught you before, consider the resistance of R1 and R2 to be R12. So 1 over R1 plus 1 over R2 equals R12. To find the total resistance, we add R12 plus R3 because they're in series. Now let's examine the current and the voltage. According to Ohm's law, I equals V over the total resistance. The current is split into I1 and I2. The total current equals I1 plus I2, while the voltage is also split. The voltage across the parallel circuits is V12 and the voltage across R3 is V3. To find the total voltage across both resistors, we add V12 plus V3. Now we know the basics of combination circuits. In the next video, we're going to talk about solving an actual complex problem.